When we talk about the workflow in general, could you walk us through maybe one use case and walk us through, like from the beginning to the end? Let's say I have a CAD model, maybe pick a specific example, and then walk us through how would this actually work? I import my CAD model, and then what would be the next steps?
Yeah, definitely. So you can start either by importing a CAD model that has been generated in a legacy CAD system, if it's there, or you can also model the whole geometry in our system. It depends a little bit if you already have data or if you are starting on a blank sheet design. Maybe let me give you an example of a bicycle frame. This is very easily. So you might have maybe not an existing CAD model, but you have your wheels and your parts, your saddle and everything that is like in place. And you want to come up with a frame design. So you maybe only import the design space because this is something you know where the size of the frame and these kind of stuff. And then you start usually by modeling all the mechanical loadings conditions for the first finite element simulations, because usually people are not starting with a parametric CAD drawing. They want to have like a hint where the mechanical properties should be placed, and if it's like a wheel, like a rim design, or if it's more like a beam design, or if it should be like some kind of ideas. And so they're using topology optimization, most of our customers, to get an idea for a first like design iteration. So what you then would do is you model your whole like FE setup and you plug in the topology optimization cell. And this cell will give you a first indication in which direction your design should go. And once you're there, we usually see that people are either directly using the result, if this is for 3D printing or for molding, and if it's more for, let's say, a sheet metal design, or in our case for the bicycle, it would be more like, let's say, a welded tube design. They try to interpretate this design from the topology optimization. We have some kind of tools in there, for example, to identify the middle lines of topology optimization, or to come up with like a blank sheet design. So there are some algorithms who could interpret the topology optimization design. And you can use them to, in the end, automatically generate a parametric CAD model, which is based on classical shells, surfaces, lines, and these kind of stuff. So once you're there, the next step would be typically to identify maybe the right wall thickness or the right parameters. Maybe you want to have like a big wall, a big tube, or a small tube. So you have some optimization algorithms involved, like, I don't know, sizing or shaping or just parametric optimization, that you can maybe run some design of experiments. Maybe you want to opt for some sensitivity analysis, to opt for different material types. So you can really play around with the design. And this is actually something which we see very often, that our customers are not like modeling one specific part. They are using the system to have creativity in the design process again. Because if you like automate the different design loops, and you can think of, oh, let's generate 1,000 design options for my bicycle frame, and I will select like the top 5 that I think are looking good, or they're just like good from the mechanical properties, and I can compare, let's say, carbon fiber design to steel design. And this is something I think which makes engineering really interesting again, to be able to be this like innovator of new things. And the algorithms that you have modeled in such a workflow help you to really explore the different variations of the design. So imagine, maybe coming back to the bicycle, you have opted for, I want to go all in. I want to have like a carbon fiber design. This is like the fancy stuff. It's my race bike. Then you select the design and you set up your final simulation for evaluation of the final design. So like the fibers and the lengths and everything, you set up the FE model, then go into some, let's say, really detailed FE simulations to really see if the eigenfrequency or the buckling analysis, if everything is like great in here. Yeah, and in the end, you end up with the final design. Maybe you want to opt some components in here. You could predict the price if you have like your historical data in-house. And then, yeah, you're ready to go. You're ready with the design. And usually what we see is that at the final step, the design gets exported again to the PLM systems like Teamcenter or Aras or Windchill, where you have like the versioning in the bigger companies.